this presentation, we're going to look at variance and standard deviations and hypothesis tests and confidence intervals for them. Well, particularly a hypothesis test in this case. So, a manufacturer of industrial light bulbs wishes to control the variability in the length of the life of bulbs so that its standard deviation sigma is less than or equal to 150 hours. A random sample of 10 bulbs was taken and tested in laboratory conditions, giving the following test results. So here are the 10 lifetimes in hours of 10 industrial bulbs, okay? And working it out with your calculator, you should get a sample variance of 35,410.99, okay? That's S squared, okay? Now, test the hypothesis that sigma is less than or equal to 150 hours against a suitable alternative. Explain your results and state any assumptions that you might make. So, if we assume that the lifetime distribution of the bulbs is normally distributed with a variance of sigma squared and all observations are independent of each other, we can use this test statistic here. So, n minus 1 times s squared over sigma squared, s squared being sample standard variance and sigma squared being population variance. And that's distributed as a chi-squared variable with degrees of freedom n minus 1. So here n minus 1 would essentially be n being 10, n minus 1 being 9. Okay? Now, under the null hypothesis, we're going to take that sigma squared is 150 to be squared, which is to say we're going to assign 150 to that value there. Okay, so effectively we're testing this. Sigma squared is less than 150 squared. Actually, I think I correctly said less than or equal to 150 to be squared. Against the null hypothesis that it is greater than 150 to be squared. Okay, now, so for this data, n minus 1 times s squared is 9 times our variance there, 35,410.99. Okay, so essentially what we're going to do is divide that by 150 squared, okay, and our answer will turn out to be 14.16. Okay, so our test statistic is 14.16. So that's not significant at a 5% confidence interval, sorry, a 5% level. Critical value, if you look it up from the chi-square test tables using n minus 1 equals 9, you should get that test statistic close to that, depending on how the tables lays it out. But essentially, we do not have enough evidence to reject the null hypothesis that the population standard deviation is less than 150. So that's just a quick introduction to this sort of stuff. So the key thing here, really, is the test statistic, okay, and with the fact that we're using the chi-square test as for the critical values. Okay, we'll leave it there.